Hi, welcome to my channel, JaberTime. Today I'm going to talk about a lot of different things. As you can see, quadratic equation, the zero product property, the square root property, completing the square, the Pythagorean theorem, the quadratic formula, and the discriminant. So let's get into it. The quadratic equation is ax squared plus bx plus c equals 0. When we set it equal to 0, and we try to solve, we look for the x-intercepts. Quadratic equations are of this form. The graph is a parabola, and a, b, c are real numbers. Of course, a is not equal to 0 because if a is 0, you don't have the second degree term, and it's not quadratic anymore, it's linear. Quick comments: if a is positive, the graph or the parabola is going to open up. If a is negative, the graph is going to open down. And here's another hint or comment that's good to know when you graph. C is always the y-intercept. I don't see it repeats a lot in books like this way, but imagine when you cross the y-axis, your x is 0. So this cancels, and that's what stays with you. C is the y-intercept. It's good to know that if the graph opens up or down, it's good to know when you factor this, if you can find the x-intercepts, but not only that, you do have the y-intercept. The zero product property says that if you multiply a times b and you get 0, that implies either a is 0 or b is 0. And that's one thing that we use when we factor. So I have it again here, so let's move on. To find the x-intercepts, we just factor and use this property. In this case right here, ax squared plus bx plus c, I have 1x squared. So when a is 1, it's the easiest way to factor, and we're going to try that as an example, which is x squared plus x minus 6. Don't forget that the minus 6 is the y-intercept. The graph opens up because a is positive. And if I have the x-intercepts, I'll be able to graph it by hand as a quick sketch. Now, x squared plus x minus 6, we're gonna make it equal to 0 to look for the zeros or the intercepts. This is factorable, and it's a quick factor. It's x minus 2 times x plus 3. You could double check. I have the n as negative 2x and the out as positive 3x. Combine them, you get positive 1x, which is right here. I get minus 2 times positive 3, which is negative 6. The principle of zero product says if a times b equals 0, either a, that's my a for now, is 0, or b is 0. Once x minus 2 equals 0, add 2 to both sides, and you get x equals 2. For the other part, b, x plus 3 equals 0, subtract 3 from both sides, and you get x equals negative 3. So the graph is going to cross the x-axis, those are called the x-intercepts, at 2 and negative 3, or differently if you want to go in order, at negative 3 and 2. Alright, that's what we have. And here's a clear graph, not by hand, as a rough graph. The x-intercepts are at negative 3, meaning negative 3, 0, and 2, which is 2, 0, because the y value is 0. That's like setting the whole thing, which is my y equal to 0. I'm finding the zeros for it, or the values where y equals 0, which is differently called x-intercepts. So the whole idea right here, you set this equal to 0, you factor it, you look for these points. You set y equal to 0, you try to find the 2 and negative 3. The graph opens up, as I mentioned earlier, and the y-intercept at negative 6, which is right there. In this video, I'm not talking about details about the vertex and more details of that nature, but it doesn't hurt to look at it quick. You have negative 3 and 2. The vertex will be halfway because this is a symmetrical graph. And 2 to the right, 2 to the left from this point. That will cover the other 2. and we are halfway between these two. You could see that the vertex is down here. And if you want to find the value of it, just plug in -half in the equation to find how far you go down. Okay? Now, to save you some time, I have everything, because I'm trying my best not to make the video like 45 minutes. I have 4x squared plus 15x plus 9 equals 0. And for this one right here, a is positive 4, so the graph opens up. B is 15 and C is 9. The y-intercept at 9, to confirm, yes, if you extend it, it's going to go up to 9 right here. Just to help support, because imagine if you go like this and you cross it at 2. Well, you're telling me that it doesn't reach up to 9, and that's the point. So it's good to know that it gets stretched to go up to 9 to cross the y-axis at 9. Okay, now, factor by grouping. This one is by grouping, it's not regular factor, because I started with a equals 4. It's not 1. When it's not 1, there's methods of factoring. One of them is called factor by grouping. We had it in a previous video, but it doesn't hurt to see it in detail right here. Here's what you do. Look at the B part, which is 15, and keep that in mind. I have a equals 4, and I have c equals 9. A times c equals 4 times 9, which is 36. Okay, everything is displayed, so just to remind you how to do it. Multiply 4 times 9, and that is 36. Look for the factors or the pair of factors as terms. That leads you back to 36. 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. But this one is written in green because I want you to know we're going to pick the right numbers that gives me the 15. Alright? It's like you're thinking about two channels at the same time. So once you multiply these two, you look at their way of factoring it as pairs, but you need those two numbers, or as a pair, you need those two numbers to add up to B, the 15 in our case. So we're going to pick on 3 and 12. So going back to the problem, it's 4x squared plus 15x plus 9. As you can see, it's written right here. We're going to write the 15x now as 3x plus 12x, and I'm keeping this in green to show you where it's coming from. Here's what we do. We're going to look at the first two terms. I separated them. I kind of like spaced them out from the other two terms to let you stay focused with me. 12x plus 9 moved, and 4x squared plus 3x moved to the left to give you some space here to focus. Out of these two terms, I'm going to take x out as a common factor, and that's what I have left, 4x plus 3. Out of these two terms, I'm going to take 3 out as a common factor, which is 3, the greatest common factor. 3 times 4x will take me back to 12x. 3 times 3 will take me back to 9. But usually this is what happens. This is the factor by grouping. Once you do the math correctly and you follow the steps, you end up with 4x plus 3, 4x plus 3 in this example, the same. Now this is a common factor between these two groups. You take it out. Let's take it out from the right side. From this package, I have x left. From this package, I have 3 left. So I have x plus 3. You could double check, of course, using the phone method and more. Now it's factored. The principle of zero product says a times b equals 0. That means either a is 0 or b is 0. So I end up with x plus 3 equals 0. Subtract 3 from both sides. I get x equals -3. 4x plus 3 equals 0. Subtract 3 from both sides. Then divide by 4. I get x equals -3/4. To support, this is my graph. It's going through -3. That's this one here. -3/4 like -0.75. As you can see, it looks like 0.75 in the negative direction. Opens up as I mentioned early. and reaches up all the way to 9, which is out of my grid. That should do it for this problem, and I think we are good. Okay, let's move on. This is the same one. I'm gonna have to skip these guys because I covered them, as you could see. Now we're looking at square root property. The square root property says if you have x squared equals k, then x by itself is the plus minus square root of k, where k is a non-zero real number. Here's an example. X squared equals 8. To find x will be plus minus square root of 8. 8 is 4 times 2. Why I picked 4? Because 4 is a perfect square. After you split the square root, this will be handled. The square root of 4 is 2. And the square root of 2 stays the same because that's irrational. And we don't like to write approximate and so on. Just leave it. That should be fine. So the final answer for this quick example is plus minus. Those are plus minus, which means, when, like for example, if I say plus minus 5, that means minus 5 and 5. Those like 2 points. So I do have 2 points here. One of them is 2 square root of 2, and the other one will be negative 2 square root of 2. Let's take another example. To solve the quadratic equation here, I'm not going to factor it or go by grouping. I know I have a 4 up front, but I'm missing the x term. So the way to do it is clean it up and apply the square root formula. We're going to subtract 1 from both sides. Now I have 7 minus 1, which is 6. Leave x squared alone, so divide by 4, divide by 4. That cancels. 6 over 4 divides by 2 both sides. You get 3, or you could leave it 3 over 2. Now x squared equals 6 over 4. Applying the property that we mentioned, the square root property, x equals plus minus square root of 6 over 4. I could see now why they did not cancel or simplify between 6 and 4. Because 4 is a perfect square, and once you apply the square root to the top and bottom side, the square root of 4 is 2, instead of leaving it as a square root. So, you know, skills practice. If you slow down, you should know things like that. You know, simplifying this as 3 over 2, but you take the square root, it's going to be square root of 3 over 2. You cannot simplify that. Okay, this one is much cleaner because you're saying square root of 6 over 2 instead of over square root of something else. All right, so that should do it for this one. And the solutions are, as I mentioned earlier, that you have to square root of 6 over 2 and negative square root of 6 over 2, which is interesting also to know that they are both identical but opposites, like on the graph. Okay, we're going to go over completing the square and how to do it. It's another method of solving quadratic equations. Here's an example. Solve x squared plus 4x plus 1 equals 0 by completing the square. The way to do it is you need to identify what's a and b. In this case, a is 1. And in this case, b is 4. X squared plus 4x equals negative 1. You move the 1 to the other side. You don't have to, but that's one way to do it. You look at the b. I'm keeping that in green. B is 4. You do side work that says the following. You divide b by 2. Take half of that. In this case, 4 over 2, which is 2. Then you square that answer. We take this 2 and square it, which is 4. Now we come up with the right number that will make this package on the left a complete square. To do it correctly, I have whatever I add to the left, I have to add it to the right to keep it balanced. So I'm going to add 4. Where is 4 from? From this right here. You always do this after you leave the x's alone. You look at b, divide by 2, square it, and that's what you need to bring in to both sides. In this case, it was 4. This will be perfect square, and this is what I mean. This is factorable to x plus 2 to the second. That means it's a square, if you graph it, of length x plus 2 and a width of x plus 2. That's what we mean by perfect square. Okay? On the right side, negative 1 plus 4 is 3. And now we're going to use the square root property. X plus 2 by itself, when you take this away, it's going to be plus minus square root of 3. Solving for x, subtract 2 from both sides. Be careful right here. This cancels, and you have x equals negative 2 next to it plus minus square root of 3. And it would be also interesting and a good practice if you want to take a, b, and c, where c is 1, and use the quadratic formula. The quadratic formula has a square root in the numerator, and that is actually what it's going to take you to. It's going to give you the same answer. That would be a good practice. So the solutions are, if you want to display them separately, x1 equals minus 2, or negative 2, plus square root of 3, and x2 will be negative 2 minus square root of 3. The quadratic formula, which I just mentioned, looks like this. Minus b plus minus square root of b squared minus 4ac over 2a. This part right here inside the square root, it's called the discriminant. It determines a lot of things. If your graph has 2 x-intercepts, or 1 that is repeated, or none. Or not only that, it tells you also if you have x-intercepts that you could look at, identify like 5 and negative 7, like real numbers that are perfect, or a rational number like square root of 2 and negative square root of 2. So this is what I have, and I have some examples for each one of them, but let me go over it quick. If the discriminant is 0, that means you don't have this. You don't have to even add and subtract. There is nothing here. It's like plus minus 0. So you end up with minus b over 2a, or as a comment, you're going to get one real solution. You're not going to get 2 choices. One real solution, and it's called usually double solution. b squared minus 4ac is positive. That means you go on. Same thing right here. You're going to have 2 choices, 2 answers. When it's negative, you stop. In lower math, we say like no solution. But in higher math, it's 2 complex solutions. But what's interesting about the graph of this one, it doesn't cross the x-axis. Okay? So going back to this one where I stopped, I did not finish this part. If this is perfect square, you're going to get 2 rational solutions. Rational, we talked about that in a lot of different videos or previous video. Rational means like 5 over 2. All these are rational numbers. Irrationals are like square root of 2. In case this is not a perfect square that you can't simplify, you're going to end up with irrational solutions. Let me give you some examples. X squared plus 4x plus 4 equals 0. A equals 1, and b equals 4, and c equals 4. The discriminant, b squared minus 4ac, you just take your time and plug in the numbers where they belong. B squared will be 4 squared. Minus 4 times a is 1. You could see that. 4 times a. Times c is still 4. Simplify it. I get 4 squared minus 4 squared again. As you can see, 4 times 4, which is 0. That means I don't have plus minus idea. It's just like plus minus 0 or one real solution. It's called double root. This is no reason to add and subtract 0. So I'm just showing it to you that you don't have that. It's not going to affect your answer. Your final answer is the opposite of b minus b over twice a, 2 times 1, simplifies to -2. The graph opens up and the vertex will touch the x-axis at -2 only. That's called in math double root. To support that, you'll have to graph it at this moment, but if you factor this, it's x plus 2 to the second, and when you're going to solve this algebraically, you get x equals -2 repeated twice. It's a root that is only one. We are expecting 2 roots, but came up to be 1. We call it double, and graphically it's the vertex. Here's another example. 8x to the second plus 14x plus 3 equals 0. I could see the 8 for A, the 14 for B, and the C, which is 3. A is 8, which means the graph opens up. C equals 3, that means the y-intercept. Let's go after the quadratic formula and the discriminant. B squared minus 4AC, that's my B square, minus 4 times A, which is 8, times C, which is 3. Do the math, simplify, I got 100. 100 is a perfect square. Those numbers are good to have to use under the square root. They're called perfect squares. 25 is a perfect square, 36 is a perfect square, 81 is a perfect square, and so on. Using the formula, look at this right here. Square root of 100, that's a discriminant, is 10. So I'm going to end up plus minus 10. And if you do the math, minus 14 plus 10 over 16, 2 times 8, that's twice A. And the other choice would be minus 14 minus 10 over 16. Simplify this, simplify this. Those are two rational numbers. I know they're not good looking like 7 and -5 and so on, but they're still rational numbers. They're not like square root of 2. If you simplify it, it's -1/4 and -3 over 2, -1.5. So I have two rational solutions to help you understand the concepts of what is happening right here, because I mentioned that A is positive and C is the y-intercept, and we have two rational roots. Adding the graph, like just quick by hand. Now -1/4 is right here. The -1.5, which is -3 over 2, is to the left of it. And the graph opens up, so it's going to cross here, and it's going to reach and cross the y-axis at the y-intercept, which is 3. Okay? That is my C, which is 3. Here's another example. A equals 1 and B equals -7 and C equals -3. The discriminant is B squared minus 4AC, that's my B squared, which is -7 to the second, that's 49, minus 4 times A, which is 1, times C, which is -3. That's going to change to positive. So it's 49 plus 12. 61 is not a perfect square. It's not like the 25, the 36, and the 49, and the 81, and the 64, and the 100. It's not. So we're going to end up with irrational numbers, and that's fine. Just applying the formula. Instead of writing here square root of B squared minus 4AC, that's why we do this on the side, to help us write less right here with the fraction. Minus B, the opposite of B, will be positive 7. Minus B minus -7, that's a positive 7. Plus minus square root of 61, the discriminant, over twice A, but A is 1. 2 times 1 is 2. So writing this as two separate answers, it's 7 over 2 plus square root of 61 over 2, and 7 over 2 minus, that's the other option, of square root of 61 over 2. If you want it approximate with a calculator to graph it by hand, that's another option. You get about 7.405 and -0.405 approximate. Here's another example. Remember, we had different cases. In this case, a is 3 and b is -10 and c is 15. Let's go after the discriminant. b squared minus 4ac will be b squared, that's minus 10 squared, which is 100, minus 4 times a, which is 3, times c, which is 15. Do the math and simplify, I get -80. That's native. That's what's supposed to be going under the square root. But in reality, we say undefined. In higher math, we use imaginary numbers to move on and solve. So we have two complex solutions. As I said, in lower math, we just stop and say like no real solution or no solution. Now, going further with the equation to describe more and graph it if you want to, x equals minus b plus minus square root of the discriminant, that's -80, divide by twice a, 2 times 3, which is 6. Now, if you look deeply into the 80, you could think about it as 16 times 5. But there's a negative in my way, so I'm gonna leave it. I can't take it out. That usually in math is referred to as an imaginary number, and we use the letter I to replace the square root of -1. Square root of 16 times square root of 5. Square root of 16 is a 4. That is a perfect square, so we could handle it. And the 5 will stay inside, as you know. This is what I have. Now splitting this to write it as x1 and y1. That's what I have for you. Of course, you could simplify more by dividing by 2, but let's leave it for now here. Now, to support the concepts of what's going on, this graph opens up, crosses the y-axis at 15, has complex roots. That means it does not cross the real number line that is being called the x-axis. There is no x-intercepts. I graphed it using my calculator to give a quick look how it looks like if you graph it to support what we are going through. Here's the graph. No x-intercepts, no real intercepts, no real solutions, complex solutions. All right? Of course, if it has something of that nature and it's opening down instead of opening up, it's going to be like down right here, like this. So it doesn't reach the x-axis to cross it. All right, we're almost done. The Pythagorean Theorem states a squared plus b squared equals c squared. And this is a graph. Those are called the legs, and this is called the hypotenuse. With a 90-degree right here, you build a square right here, you build another square right here, that's called b squared. A square here will be an area of a square. That will add up to a square right here, which is called c squared. As an example, one of the legs is 4. The other leg is missing. It's being called a now. And the hypotenuse is 12. To solve for a, what you need to do is just use the formula, some algebra skills, and finish it. Let's take a look. A squared plus b squared equals c squared. So I have a squared missing plus b squared, which is 4 squared, equals 12 squared. 4 squared is 16, 12 squared is 144. Subtract 16 from both sides, I got 128. 128 is not a perfect square, but inside it I have a 64. Now this takes more time from some students than others. It's like it takes time to do it actually. You just have to break it down if you want to do the prime factorization to find what is inside it as a perfect square. In this case, it's 64. 64 times 2 is 128, but 64 could be handled under the square root because it's a perfect square. Square root of 64 is 8. Square root of 2 stays unless if you want to round. And a is 8 square root of 2. Exact or approximate. You could do that too. So that should do it for now, and I'll see you in the next one. Tried my best not to make it 45 minutes video, and it's about 30 minutes. Thank you for watching, and I'll see you next time. Thank you for watching. Don't forget to hit the like button, subscribe to see some more, and I'll see you in the next one.